In this video, I'm going to go over how to program points for drilling. So I have my layer for my drill points here. If I right click and do select objects, you can see that selects all my points. Now I'll go over to machining operations in the RhinoCAM toolbar. This is where each of our operations can be found. So you can see there's the 2-axis menu, the 3-axis menu. The drill points is over here in holes. So if I click holes and then go to drill, I can create a drilling operation here. That's going to bring up this dialog window, and if I deselect my points, you can see we have these sets of tabs, and in the first tab we have our hole features here, and if I select one of these, you should see it's highlighted green over here in the Rhino window. So this is, we have 12 points total for these 3 parts. That's all we need to worry about for now in this window. As we do the programming, I'm going to work through these tabs left to right, and a lot of these will be similar going forward as we look at some of the other operations that we're going to do. Moving over to the Tool tab, in here, as I mentioned previously, the tool libraries that we have will have available to you, but they should already be loaded on the computers that you're using. So this is all the tools that we keep in stock in the lab, and each tool has a different setting depending on the material that it would be used for. So some of these tools physically are the same tool that we have in the lab, but the tool library just has different settings for which type of material we're cutting. I'll try to explain that a little more. For this operation, we want to use our 3/16 inch drill. You can see that it's noted for softwood, and that's because the default settings are for softwood. This will also work for plywood. In this instance, we're setting this up for 3/4 inch plywood. What I want to do is select that tool, and I talked about order of operations, and that translates to the physical setup of the CNC machine, in that typically what we want to do is the first operation, the CNC can have multiple tools for each different operation. It can have up to 5 tools, and each one of those has an individual tool holder. And the way we identify those tools is just with a value, a number 1 through 5. So for my first operation, I want to make that tool 1 because that's going to be the first operation. So I'll load the tool that I need for that first operation in the first tool holder, and that helps me sort of think chronologically, step by step, when I'm setting up the machine, loading all the tools, and preparing the machine to start the actual cutting. So you can see this number is already tool number 1, but I'm going to go in and show you how to change that. If you click down here, Edit, Create, Select Tool, we get all the different tool settings, and so we made this library by sort of measuring all these measurements on our tools and populating them in here and giving them new names and saving the new tools. So this was all built by our staff, and these are things that we can change if we need to at any time. For the most part, we don't want to change them. We want to just rely on the work that's already been done. So all we need to do to change the tool number is adjust this setting right here. So if this was going to be my second operation, I could change this to tool number 2, and if I click Save Edits to Tool, it'll give me this pop-up asking me to confirm. If I click OK, Now if I click OK, you can see my tool number changed there. I'm going to go back and just change that back to tool 1. Okay. One other thing I wanted to point out as part of the tool settings in the tool library, you can see the other tab here is feeds and speeds. And so at the top we have the spindle speed, so this is how fast the spindle is spinning. For drilling it's going to be a bit slower than for when we're cutting or doing profile cuts or pockets or engraving with a router bit. In this case we're using an actual twist bit, so it's a similar speed as we would use on the drill press in the shop. The feed rates are the travel motion of the machine. So you can see it's in inches per minute. So the machine's the z-axis is gonna move at 30 inches per minute, and everything basically is set to 30. So it's gonna be 30 inches per minute. These values, there are calculations to help determine these values. What we do when we make the tool library is follow those calculations and then run some physical tests just to make sure that the settings are all correct. So I've changed my tool to tool number 1. I'm just going to exit now. The next tab is feeds and speeds. This tab, all we want to do here, this should auto-populate with those feeds and speed settings that we just looked at from whichever tool we have selected here. But if we decide to change tools, they may not change automatically, so we want to just click Load from Tool down here, and that will make sure that we have the correct values for the type of tool that we're using. The next tab is the clearance plane. I think the default value here is going to be one of these part max or stock max. I like to use this button down here, which allows us to set an absolute value, and what I recommend is making this value at least 1 inch above your material. The reason, so this clearance plane it's a plane that the machine will move to as it transfers between cuts. So once it's done cutting out the top part, it'll move up to the clearance plane, move over, and then move down and start to cut the second part. We want the clearance plane to be about 1 inch above the material, and we want to make sort of a mental record of what we're setting the clearance plane to, because when the machine starts, the first thing it will do is pick up the tool, lift up, start the tool spinning, and then it's going to move down to the clearance plane to come out and do its first cuts. And by having an idea of what we should expect, what height the machine should be at, we can watch it carefully and make sure that if it looks like it's too close, maybe we missed something, we missed a step, or we forgot to update a value, and we should go back and check our programming. So it gives us a visual cue that something may be wrong, or that the machine's behaving the way that we expect it to behave based on the program that we made. These automatic and the part max, those rely on the model that you have in Rhino. So if you have geometry that's sitting elsewhere in Rhino, anywhere in Rhino, and you have this part max selected, it's going to set the clearance plane based on that part, and that can lead to errors in the program and cause all sorts of issues. So once again, that's why I don't like having a lot of other geometry in the file, only the stuff that we're looking to program right away. That's all we need to change here. So for most ply materials, I know we have 3/4 inch ply. In this case, I'm not doing 1.75. I'm just doing 2 inches. If usually with ply material, that's sort of a standard that I'll use so that I know that I'm looking for the tool to go to 2 inches, whether I'm cutting 1/2 inch ply or 3/4 inch ply. I'm always looking that the machine should be at about a 2 inch height off the table. Moving on to the next tab, this is where really the bulk of the programming is done. So this is where we're going to assign exactly the motions of the machine. The first thing we can see at the top is there are drill types. Standard drill is the default, and that's really what we want. We also use commonly the deep drill, and so deep drill allows you to add a step increment. So if you're drilling a 4-inch deep hole, if you've ever done that on the drill press, you know you need to sort of clear the hole periodically. And the deep drill allows you to break like a 4-inch deep drill into 1-inch heights. So it will drill down 1 inch, clear the hole, go down 2 inches, clear the hole, go down 3 inches, and so on. But for 3/4 inch plywood, we can use a standard drill, and we can drill through that all in one pass. The next thing we want to look at is the depth. So we want to drill all the way through this plywood, and in this case we're using a twist drill bit. So if you look at the diagram here, and if you're familiar with the twist drill bit, it has a tapered end, and so the end of it is kind of pointy. So if we only drill 0.75 deep, the very point of that tool is going to hit the bottom of the table surface, the spoil board, and it's going to move, think that the hole is completed and move back up. But that will just barely, the point will just barely break the surface. So we actually want to go past the bottom slightly. And the CNC machines have what are called soft limits that prevent the machine from going too far negative. If it's programmed to go -1 inch, it will not allow you to do that. It'll sense an error and throw an error. And the threshold for that is -0.025 inches. With a twist drill bit, I'm going to use all of that, and I'm going to set it to go as deep as it possibly can. So I'm going to add 0.025 to my drill depth. So I'm going to have 0.775 as my drill depth. The next area here is the location of the drill points. Just like the clearance plane, there are some options here, and I could say that my points are at top or at bottom, or I can pick the point that I want to start at. So if I like to do the pick option, and then I just type in the thickness of my material. So I have 0.75, and so that's saying start at 0.75 and drill 0.775 deep. The reason that I don't want to do, so my points right now are at 0, so I could say at bottom, but then I'm going to drill 0.775 above that 0 point. So I'm not actually going to go below 0. And so I like to avoid, in general, having programs rely on the physical location of the geometry in Rhino. It's very easy to accidentally drag something around and end up moving something by mistake, and that can affect the program in bad ways. The next section we don't have to worry about. We can leave that by default. Really the next three sections. Under Engage Retract, you can see this approach distance. This doesn't need to be adjusted, but sometimes if your material isn't flat, if it's sort of cupped or bowed or wavy, we may want to increase the approach distance slightly so that as the tool travels, if this approach distance is too close and your material's lifting up in areas, we may drag the tool across the surface. But generally the default value is going to be fine. The last tab, we don't necessarily have to do anything with sorting, but this can be really handy if you're drilling lots and lots of holes. It's hard to say which setting will give you a more efficient result, but you can always select one setting and generate the program, look at it, and then come back in and change it later and see if one option or the other looks more efficient. I think usually minimum distance is going to be the more efficient way. So with all that done, I'm just going to click Generate. And so now you can see we have the red lines represent the travel between the points. The cyan represents where it's actually drilling the material. And so that's what our drill operation will look like there. If I wanted to, again, I mentioned if the sorting, if we wanted to try the other setting, I can double click the folder, go back to my sorting, change it to directional, and click Generate again. So you can see that's it's quite a bit more travel. We're going back and forth. So I don't like that. I'm going to double click the folder again, go back to sorting, click minimum distance again, and generate. And I think that's a more efficient solution. Okay, that's how to set up drill points. We'll look at some of the other operations in the next videos. Thanks.